Hello, welcome to the Self-Learning Podcast by Dr. Sushma Singh. Let us start discussion on Unit 30, Using SPSS for Data Analysis Contents. We are starting Step 3. Defining missing values. Sometimes your data may contain missing responses for a variety of reasons. Assign a missing value to the variable if necessary. For example, if the sex category of a person is not available, you may assign the value 9 to indicate the missing value. The missing value indicates to SPSS that the response is not available and should not be included in the data analysis. Remember that the missing values you have assigned to a variable are present in their respective positions in a data file. You can also specify the width of each column in the cell under column heading and the alignment right, left and center in the cell under align column heading. Specify the type of measure in the cell under measure headings. Now you can define all the information for variable. Move on to the second row, the third row, to define the rest of the variables in that order. You have defined all the variables. You may like to see the generating variable definitions. For this, select Utilities File Info command on the menu bar. This will generate file information in the output window that can be printed if you need for future reference. Step 4 is entering the data into the cell. Once all the variables for your data file are defined, the data can be directly entered into the cells. For this, first change the view to data view by clicking the data view button. Once you have entered the data, it is a good practice to save the data in a file. This will avoid not only repeating the data entry but also for all future uses of your data. SPSS distinguishes between two types of files, data file and output files. The data file contains the data you have entered. The output files contain the output of the data analysis you have performed. You need to save these files in case you may need them for future reference. Often you might have entered data in an Excel worksheet and want to use the same data set for analyzing the data using SPSS. SPSS can easily open an Excel data file and some other types of data file. Now let us move to the next point, Uni Variant Analysis. Data can be analyzed in a number of ways. You can present the data in a simple frequency table or use statistical technique. For the analysis of data, the data file should be opened first. If the data file is not already open, select the file and open command from the menu bar. The open file dialog box appears. Choose the file location, SPSS data file name and click OK button. The data may now appear in the data editor screen. SPSS offers several tools to analyze the data. The tools are selected from the Analyze command on the menu bar. In this section, we will learn how to generate frequency tables and calculate the univariate statistical. Remember that you can compute the same statistics in SPSS using alternative command. In analysis, observe that the tables contain all the information you want. Also, you have information on the missing cases for each variable. You also have three types of percentages, one for all the cases including missing cases under the heading percentage, the second one for only valid cases under the heading valid percent, and the third gives cumulative percentage under the heading of cumulative percentage. Now you may want to print on paper or save in a file all or part of the output available in the Output SPSS viewer window. In Uni Variant statistic, for each variable of your dataset, you can calculate measures of central tendency, mean, median, and mode, dispersion, standard deviation, variance, ranges, standard error of mean, etc., distribution, kurtosis, and skewness. Remember, in SPSS there are some restrictions on the choice of measures of central tendency, mean, median, and mode that can be calculated on any data set. The choice of mean, median, and mode is restricted by the level of measurement of a variable you have defined. If the level of measurement of a variable is nominal, you can calculate only mode. If the level of measurement of a variable is ordinal, then you can calculate mode and median. If the level of measurement of a variable is interval or ratio, you can calculate mode, median, and mean. Remember that you should opt for only appropriate statistics. For example, there is no meaning in opting for mean of a sex variable, since there is nothing like mean of a sex distribution. Now let us discuss bivariant analysis. Often you may be interested in comparing two sets of data or variables to explore the relationship between two variables. In this section, you will learn how to cross-tabulate the data, coefficient of correlation, linear regression, and coefficient of variance to compare two variables. To capture any possible relationship between two variables measured with categorically data, you may use bivariant table, which is also known as the cross tabulation. To cross tabulation, two variables follow the step of bivariant statistics. The statistical tool you often use to compare two variables may be the coefficient of variance, correlation, and linear regression. Coefficient of variance, as you are aware, the coefficient of variance is the standard deviation expressed as a percentage of the mean. CV is equal to standard deviation divided by mean and multiplied by 100. Unfortunately, SPSS does not have a command to complete the coefficient variance for a variable in a data file. What we advise you to that you should calculate the respective mean and standard deviation of a variable using the descriptive dialog box as explained earlier, and then calculate the CV by hand, which is very simple. Now let us discuss correlation coefficient. There are two types of correlation coefficients: Pearson's correlation coefficient and Spearman's rank correlation coefficient. The Pearson correlation is appropriate and applicable when you have interval or ratio data. The Spearman rank correlation coefficient is applicable when you have two ordinal scales with a large number of values, or one ordinal and the other interval or ratio scale. Let us discuss linear regression. The linear regression technique is used to test the hypothesis concerning the linear relationship between two variables, estimating the specific nature of relationship, and to predict the values of dependent variable when you know the values of independent variable. Observe that the output consists of 4 points: a table of variable using in regression, a model summary, an ANOVA table, and a table of coefficients. You may be interested in a portion of output. You will explain how to select a partial output in another unit on use of SPSS in report writing. Now let us wind up the session and take rest. Thank you very much for engaging yourself with the self-learning podcast.